one another, the electric current could not follow its proper path. But suppose we cover that wire with some silk insulation. Now we can wrap that wire more tightly and in many more layers, and we know that the more that turns the coil, the more powerful magnet that we can make. And that's what I discovered in 1827 here in the United States. I now begin my demonstration. Here we have one of my electromagnets, and as you can see, there are many, many turns and coils of wire around this horseshoe-shaped iron core. And as I said before, the more the revolutions around the magnet, the stronger the magnet will be. Now, this particular electromagnet weighs only 7.5 pounds. At this point, I would like to have members of my audience, my students, indicate to me what they believe would be the possible potential that this electromagnet could hold. Again, at 7.5 pounds, by way of thought process, I would suggest to you, are you able to lift your own weight? Would you lift twice your weight? Would you lift 3 times your weight? Think of that, and then think of what this electromagnet may be able to do. Do I have any thoughts about that? Sir, do you believe that this magnet could lift at least its own weight? 7.5 pounds?
Yes.
Any more, any less?
More.
More? How much more?
I don't know.
How much?
I don't know.
You don't know. All right, so at least 7.5 pounds. Does anyone else have a more definitive response?
It's hard to tell.
5 times. 5 times that. So 5 times 7 will be 35, and then another half of that would be another 7. So we're beginning with around 42 pounds. How does that sound, everyone? Does that sound reasonable? Excellent, then. I'm not going to tell you. I'm going to show you. And you are going to help me. And now I reveal to you the instruments of our experiment. We have buried blades. And here we have a battery. And you can see the wires moving upward, and they come to the electromagnet to be. Here we have a platform, now empty, and we have an iron armature attached to the platform by this rope. Now, there is no electricity in the iron core. It does not hold. I require an assistant, a volunteer to assist me. Yes, very good. Step forward. How are you? Good. Now, will you do only what I say and nothing more? Excellent. This is a switch. I want you to turn it counterclockwise until it rests on that bolt. Can you do that? Excellent. And now, as you can see, the electric current is coming from the battery up through the wires to the electromagnet. And what will happen to the armature? It holds! So, where there's electricity, there is magnetism, and the magnetism holds up the platform. I'm not done yet, sir. Please come back. Now, would you turn the switch off? It fell. Why did it fell? Well, students, I apologize for my terrible English. Why does it fall? What force pulls everything down to earth? Gravity. This young man is absolutely correct. You all agree that it is gravity that does so?
You didn't know the answer?
Sissy, turn on the switch again.
You did?
All right, so you can feel the electricity going through the coils up to, and it holds. So where there's electricity, there is magnetism. And now electromagnetism has overcome the force of